Let's get started on the next part of this here, continuing our journey here. In the last few videos, we have learned about references, pointers, dereferencing. Well, not learned, discovered, I should say, because there's a lot more information on those, and we got a lot more to learn on those. But like I said, going through all this material um, has taught me a bit more. Not as much as I'd like to know already, but we're getting there. And that's the whole point of all this. So, um, let me adjust this screen real quick and we will get started on the next part. Uh, there we go. If this is the first video you've seen so far of this, I have several videos already out there on pretty much everything from uh, writing code to this point, which is modifying pointers. So my previous videos from here, just as a recap, are the sources I use to learn how to write C++. Give me just a second. All right. I love the fact that I can sit there and pause the recording when get interrupted, so that's good. Anyway, so as a recap, like I said, I paused the recording, so I wasn't sure where I left off. But so far, my videos have been the first one start off with the sources I use to learn C++ and how I go about writing code. So if this is the first video you've seen, this right here is W3 Schools. Has a lot of information on C++, mostly discoveries is what I want to call it because it doesn't get into the finer points of what you can do with C++. So if you want to know more about my sources and how I'm learning this, go back to one of my first videos and you'll discover that. Also, and that's what is on the right side of the screen here is W3 Schools. What's on the left side of the screen is a text editor, which is what's required to write programs in any language. Um, I've also got videos on uh, different types of text editors and kind of how to use them, kind of. There's a lot of information on text editors and that sort of stuff. This one right here is VS Code. I know of another one called Code Blocks. I think there's another one called Virtual Studios. VS actually stands for Virtual Studios, so don't get those two mixed up. VS Code has a blue emblem where Virtual Studios has a purple emblem, I believe. But yeah, if you want to write code and stuff, then you're going to have to first off use a text editor, which every system comes with a text editor. For Windows, it's Notepad. For Linux or Mac, there's one built into those. There's external ones that have additional things that kind of help you out. VS Code here has extensions, which makes it kind of unique for any code you write. You're just gonna have to read the information on them and everything like that. But yeah, pretty much to write code, you need a text editor. You're gonna have to set up files and folders to keep everything together and to keep everything working, especially if you have multiple files for whatever program you're running. So yeah, that's enough of the recap for now. Like I said, go check out the first few videos I've gotten out there or any of the videos and stuff. I think I've gotten them pretty well labeled, but I could be mistaken. If they need to be relabeled some way other than that and stuff, you can leave a comment and I can maybe edit the labels on them or whatnot. So anyways, let's get going with this. We still got quite a bit of information on this. In fact, for just the tutorial right here, if we're looking at the right side of the web screen here, the W3 Schools, we're almost through the tutorial, which we got modify pointers and memory management. Then we're going to go into functions and then classes, and then errors, which errors is basically a way of figuring out what's wrong with your program to correct it. Now, a lot of the text editors that you can download and stuff will show the errors that you're making, but some of them, like Notepad, will not. If it won't run for some reason, you're gonna have to go through it and figure out what's wrong, what you messed up, what you forgot, what you misspelled, etc. And then we got data structures, as well as namespace, projects, certifications. So yes, this website right here, you can support it if you are interested in this website. Maybe they have more to offer than what I'm seeing on the free part of it. They do have an upgrade part right here. You can check that out if you're interested in supporting the website. They have an academy part right here. I'm not sure what all they get into or the certifications. Um, and then uh, how to area, maybe a random number generator right there. Add two numbers. I'm not sure what that is about. I haven't looked into all of it yet. And then references, which references kind of, it's not the same references we went through in the last video. References would be like types, keywords, um, what are in many of the libraries, it looks like. And then it looks like it has an area for examples right here, so you can go through. And some of these examples may be examples you've already done, but yeah. So far, we are almost finished with the tutorial part, getting ready to jump into functions, which I kind of like the functions area. That that is what kind of makes your code seem to work a little bit better. But like I said, let's get started on this. Modifying pointers. Modify the pointer value. You can, and I just basically read directly from the website here and then try to make comments through what I see. And like I said, I'm not 100% correct on this stuff. I'm still learning this stuff like anybody else. So if I make a mistake in the videos or something I say, go ahead and leave a comment of correction. If you have a question, I can maybe help you out with, C++. I have done a little bit of study on HTML, CSS, maybe with some text editors or the sources I use to learn this stuff. I don't have anything linked in the descriptions or anything like that. Um, but let's see. You can also change the pointer's value, but note that this will also change the value of the original variable. We got an example right here. It looks to be a lot about like the example we had up here before, but we substituted some stuff on this previous code right here to kind of label what this stuff was, like data value. So your value right here is your data value, data storage location, so your variable name, sort of thing. So if you're curious about what these names are and stuff and what they represent, I've kind of labeled them myself. It's kind of how you want to do variables anyways. You kind of want to label them for what they are. Um, in this case and stuff, this label wouldn't work for if you were building a program like a game or something for something else. You may want to label this to understand what the value is representing, sort of thing. So, but we are going to go ahead and do this exercise right here to show how to modify a pointer value. I'll make edits to it if I need to, but for now, let's go ahead and clean up the screen right here so it looks all fresh. Um, and then we will go through and try to describe. Maybe I'll relabel stuff at that point in time. So, um, also, my code doesn't look exactly the same as theirs because their example uses namespacing, which is something that goes above the main function here. And I don't have that in mind, so I have to actually use the standard key part of it. That's also one of my previous videos. I was trying to recall where I seen that at. There is a section on that up in here, but also if you want more specifics on namespacing, there's a section right here labeled namespacing and stuff to kind of tell you the difference between my code and their code. But I also can show you through the try it yourself section, which if you click on that, you can see their code and stuff and see how it differs. So let's get started on this. Type this out here, standard string food is pizza again. Standard string. Then we got a pointer here, a reference pointer. PTR, which I believe is the abbreviation that they're using for pointer to tell you that it's a pointer. And then a reference for food. There's a couple spaces down, and we got a comment here. Output the value of food, which is pizza. And then in a line of code, standard output food. Oops. Another comment here. I'm gonna adjust my table here. Maybe that'll make it easier for me to type. Access the memory address of food and output. Go down here a line so I don't go right off the page here. Its value, which is pizza. And then the code for that one right there. Output. Now, if you paid attention to the previous video, this right here is not the same as the top one up there. This one right here is a dereferencing the pointer to change something. Also, one of my sources that I use, if there's a particular section that I'm going over and stuff, it doesn't make sense to me, and I'm just trying to make sense of it myself, or it doesn't make sense to you, one of the sources I use is the Cherno. He's another YouTuber and stuff. He's slowed down on making videos, but he goes through all this stuff in much better detail. He has a much better knowledge base of this stuff than what I do currently. He's been studying it a lot longer than what I have, I think. Um, yeah, I know of. The change the value of the pointer. So the dereferenced pointer will be changed to hamburger. Another comment, output the new value of the pointer. New value, which would be hamburger. Standard output. Now we're going to output that to the terminal what the new reference is, or what the new, yeah. I'll explain this as best as I can once I get done typing this. I'm just kind of try to say it out. I do whatever I can to uh, learn this stuff the best I can, and sometimes I say it out loud, sometimes I don't. But it's all about the idea of learning it and getting it locked into memory. And whatever I can do to do that is more beneficial. Everybody has their own ways of doing that sort of thing. So, all right, and yeah, it's gonna run off the screen a little bit. That's fine. Standard output of this last one, food. I think we changed food right there. Change the value of the variable food. All right. So at the top here, we're declaring a string, giving it a variable name food. The second line here, we are making a pointer to reference food. Like in my previous videos and stuff, the pizza is the value, food is the variable name, but food is also a has a location. Using the pointer, we can reference that location. And a comment here, output the value of food, so we're just going to basically print out what food is, which will read pizza. The second comment here, access the memory address. So here we're going to access the memory address. This should give us a memory address. No. Will it give us a memory address? No, we're going to dereference it. So we're going to actually print up the value of pizza using the pointer. So normally if you just had pointer right here, it would print out the memory address, but since we are using the asterisk here, we're going to dereference it, and pointer is actually going to represent the value of food. Now, in the next one right here, we're going to change the pointer value to hamburger. So even though the pointer value has the reference of food, we are going to change it right here so that it is hamburger instead of pizza. So then we dereference the pointer again, and instead of it having the value of food of pizza, it'll end up having the value of hamburger. Because right here, pointer is actually PTR is actually a pointer referencing this location. Here, we are dereferencing it and then giving it a new value. Here, we are also dereferencing it and outputting it to the terminal. Again, if I do not have that correct or I'm not saying it right and stuff, feel free to mention it in the comments and stuff. It happens. I'm still learning this stuff. Lastly, we're going to again output food. Um, in this case, I'm not sure if food is going to remain pizza or not. Let's see here. I don't think we've changed the value of food. If it was pointer, just regular pointer, because this is just dereferencing pointer to give it a new value. If the asterisk was not there, then yes, the PTR would change its value to hamburger, and therefore uh, food would have a new value. But I think since we are dereferencing it right here, we're just changing the value of it. So pointer actually is no longer the reference of food. So I think this is going to end up printing out pizza as well down here. But let's check. Let's go ahead and save it. Control S, run the code and see what happens here. See how accurate I am. So I was inaccurate. Um, food obviously getting printed out right there is pizza with that's value, dereferencing the pointer instead of getting the location of it or the memory address of it. We are getting the value of food. The value of actually not value of food. The value of what's in the location of food. So, like I said, that's quite confusing if you're not paying attention. Now, we change the value of the pointer. So apparently, like I was saying, I was wrong about that. Um, pointer, yep, since PTR is referencing the food location, whatever's in that location is going to be changed to pizza. So I was wrong the first time around. I'm seeing it this time. It's basically learning it again. Um, and as I continue doing this over and over more and more, uh, I will get used to it. Right now, it's still kind of like a puzzle in my head, and I'm still trying to put the pieces together. And until I get all the pieces sorted out and see the picture in full, I'm going to get things wrong. So now there's no other information on this, but I'm going to read this one sentence again. You can change the pointer's value, but note that this will also change uh, the value of the original variable. So since we changed pointer, the reference, we changed the original value. That's what that was getting at. So that's pretty much all this has on modifying pointers. Again, this is not really a lot of information on it. I don't think you can sum up this in one sentence or one example, but learning that you can do it or discovering that you can do it is very beneficial. So we will move on to the next area. Because like I said, this part of the journey is more of what I went through the first time, me relearning all this stuff again. And like I said, comments are there if you need to make them. So moving on. So memory management. This one right here, I'm probably going to be lost on too. Memory management is the process of controlling how much memory your program uses and how it is used. This includes creating, using, and releasing memory when it is no longer needed. I don't know if they mention this or not, but I do recall, if you're not careful with your code, and maybe this is later on in the website, if you manage memory and you're not careful with your code, you can end up with what's known as a memory leak. Um, I've still got some work to do to learn about that, so I just know that memory leak is possible, and I don't fully understand it either, so I couldn't answer the question on what memory leak is. So, still learning that. Memory in C++. When you create a variable in C++, like this one up here, this variable, um, the compiler automatically reserves space in memory for it. So the memory location is actually not created until a program is run. Once the program ends, that memory slot should be cleared up. It should have nothing in it anymore. But while the program is running, there's a slot in the RAM of your computer, known as memory, that is holding a value. Most of these programs that I'm using, pretty much, if I was to try to open them, they would open and close pretty right away, because once a program's over, just like any program, you finish up a video and stuff, it's done with that. That video is no longer in your CPU or memory. It moves on to the next uh, video, like in YouTube. So, as far as I understand, anyways. For example, this right here is giving us an example. So, integer mynum10. When you run that, there's a location set for mynum, and this is the value that's being held in that location. Once the program is done, so forth, so on. Which I think this next line is getting ready to say something about that. So the line above tells the program I need space to store an integer, which if you recall, an integer takes up 4 bytes. So C++ handles the memory automatically, so in this case you don't have to worry about managing memory. So in order to manage memory, though, you have to know the sizes of all the different types or what you're using. And this is how we can check. How you can check, or you can check memory, how much memory a variable type uses with size of operator. We've seen this before, but we didn't actually have any kind of explanation of it before. So we got some new code right here. And everybody's system might, no, it should be all the same. Yeah, it'll be all the same on this because we're determining how much memory each one of these types takes. But how much memory can your PC actually hold is a different story. So depending on the RAM you have in your computer will determine if it'll hold up to this amount of bytes. Most systems will. Most systems are built with 1632 or higher uh, amount of storage. Can't remember if it's gigabytes or I think it is, but I can't remember. Anyways, so let's clear this code out right here because we typed it in there as an exercise. We checked through it. I was trying to guess before I printed the code out as to, well, not trying to guess. Some of this stuff I already knew, like I knew food that would print out pizza. I wasn't sure if the second food would. Um, the pointer here I knew would, but the change right here, because I can't remember how this change exactly works, I wasn't sure what these were going to print out. But let's keep moving forward with this as we keep going and stuff. I'll keep learning more. Like I said, I've gone through this once before and stuff, but it doesn't always stick the first time. It's kind of like one of those questions. I think I remember this on a TV show I watched and stuff. Um, you take a quick glance around a parking lot or whatnot, and you close your eyes, and somebody may ask you, or you look a different direction, somebody may ask you, so uh, how many red cars are right behind us in this first row? Or how many blue cars? Or how many doors or how many entrances are there to the building that the parking lot's holding for? Sort of thing right there. And that kind of short-term memory and stuff is, some people are better at it, some people exercise it to get good at it. Um, I'm working on building that memory for myself. So, anyways, this example right here actually shows using namespace. which is good because using namespace std right here is an indication that they don't need to actually add std in front of all these couts right here. Um, it's also where this comes from. So where I've got this right here, they've got namespace. If I didn't have this right here, then I would have to have it up there. But you have to have this somewhere. So I prefer to type it right here. They prefer to type it at the top. They may change it later on. But again, let's clear this out and get started on this first example for getting memory size. That way we understand a little bit more on how to manage memory. Let's see, the first one's going to be, we're just going to basically declare 5 different types, or 4 different types it looks like. Float, my float, yep, oops, declare, there we go. Got double and char, so double, my double, declared, and char, my char, declared. And then next, in this example, we're just going to output each one of these, but with using the size of operator to determine the size of each one of these types. The type is what determines how much space is reserved for whatever the value is. Not the value itself, the type, not the variable name. The variable name is normally the location of it, but the type. So in a sense, even though we have, when we write out a statement, we have the type and then the variable name and then the value it is set to. Oops. And I probably ought to put this value space, put this all in a comment so it doesn't do that. Another comment here, so I want to kind of reiterate this. So that's your statement right there. The type determines the size. You have to use the variable. Actually, type determines the size. Variable is just the name of the value. But you have to use the variable name to determine the type's location, as far as I know. I could be wrong. And then the value is pretty much just the data that you either input or a user puts in. So the value is just data. Can be put in, can be entered by the programmer or user. So, and there may be more to this and stuff, but so far that's kind of what I understand of it. Anyways, let's keep moving forward with this. Let's get the rest of this put in here. I don't want to make this video longer than it has to be. I made quite a few of my videos already long enough. Of my int. Oops. New line. In fact, we're going to just simply copy this because we're going to type this out 5 times. Copy, paste, 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 paste. And the only thing we're going to change is this part right here. So float, double. Actually, I guess we don't need it 5 times. I guess we only need it 4 times. My bad. And char. So this one we don't need. There we go. Save. Doing this right here will tell you, once you get used to this, you're going to know this right off the top of your head. But what else can size be used for? It can be used for, size of can be used for so much more than just to tell you the size of a type. A lot of people will even use size of to change things around. Divide this by that. We've done that before. So divide the size of this by the size of that, or whatever. Save that, run that, and we get the exact same results they have right here. So in the comments, they have 4 bytes. Now, I don't actually have what these numbers indicate. If you want to add that in there so it's more, makes more sense to you, I can put it in here at the top right here. So this right here is put some text in here, 4 bytes of memory. I believe that's about right. Control save. Oh, no. One more thing to add in there. There we go. And then run it again. And that way you can see it right here. 4 bytes of memory. 4 bytes of memory as well. 8 bytes of memory. 1 byte of memory. So an integer takes up 4 bytes of memory. A float takes up 4 bytes of memory. A double takes up 8. And a char takes up 1. Now, this is not changed by the system. So if you're running Windows, Linux, whatever, your program, that does not make any difference on this. These values are set in by C++, not by the computer you're using, not by the system. But if your computer that you're using or the program that you're using will not manage 8 bytes, which most every one of them will, unless you're using something from more than 20 or 30 years back. Every one of them will do this. So every time you print this out and stuff, you should get the same results because this is programmed into C++, the language itself, as to how many bytes these are supposed to take. Can you increase or decrease it? You can, but that is another very much complicated um, area of study that we have not even gotten close to yet. So for now, just know that an integer takes 4 bytes, a float takes 4 bytes, a double takes 8 bytes, and um, a char takes 1. So we haven't even gotten into what bytes are really, honestly. So moving on to the next part. Knowing the size of a type helps you to write more efficient code, especially in large programs. Just keep that in mind. Give me 1 second. All right. So I guess here's a question for after this example here. Do you have to manage memory yourself? Depends on the program. That's why it says right here next, sometimes yes and sometimes no. If it's a small program, then no. Or if you have a very small a computer that has very low memory in it, a low amount of memory in it, that's not an issue for me. It might be more of an issue for the laptop, the old laptop I got sitting over here, but not on this PC right here. So sometimes yes, sometimes no. That depends on the program and it depends on your computer. There's a couple variables in there. Some notes it's got right here for normal variables like int x is 10. C++ takes care of memory for you. But when you create a memory manually while the program is running, but yeah, it's okay. But when you want to create memory manually while the program is running, for example, based on user input, you need to manage it yourself and clean it up when you're done. Clean it up when you're done. So they are probably going to get into memory leaks on this. If your program uses too much memory or forgets to clean up memory, um, to it no longer needs, it can lead to slow performance or even crashes. Let me say that one more time because I paused in that trying to read that. If your program uses too much memory or forgets to clean up memory it no longer needs, it can lead to slow performance or even crashes. What that means is, so first of all, if uses up too much memory. So that would be morely an issue where the program is massive and your computer doesn't have the memory capacity to hold the program. It would lead to slow performance because when it's trying to place something in memory and there's no room for it, it's like trying to push a bunch of people onto a bus at one time. You've got 100 people trying to get onto a bus and they're all crowding the door at one time. So either one, people are getting onto the bus slow, or two people get stuck in a doorway at one time, like it talks about with not cleaning it up, and now nobody can get through it all. So then the line no longer moves anymore. It crashes. Uh, the other part of this forgets to clean up the memory it no longer needs. So if for some reason, and this shouldn't really happen too much anymore, I'm not even sure when this happened and stuff. I probably a long time ago, but if you have traces of programs that are still left over in the memory of your computer, um, and you're no longer running that program, this tends to happen a lot with applications you download, programs you download. Um, if the program or the code for that program or application or whatever is not set up properly and it leaves traces of memory in it, it can cause a slowdown or crash. This is also another reason why you should think twice before just simply downloading something. If you don't trust it, it's more the idea of trusting the person that built the program more than it is about trusting the program itself. Because you can create new memory, and while the program is running, it'll end up sliding uh, or putting things into memory that won't come back out because there's an idea of create new memory for this right here, create new memory for this right here, and they don't delete it. So it stays in there. It stays in that one spot. I think that's what's referred to as a memory leak. In most programs like the ones that we're creating here for these examples, that doesn't happen. These spots get filled up, but as soon as the program closes, those spots get deleted, unless there's something wrong with your system, your computer. Anyways, moving on. That's why understanding memory is important. It gives you more control and helps you avoid common bugs. There's something else I want to mention about that too. If for some reason your program, there is a way to look at your memory, all your memory locations, which if you have a lot of slots in your memory or a huge chunk of memory, like I said, I'm thinking that 16 or 32 gigabytes of memory and stuff is more of a common thing. I may be wrong on that. But if you only have like 4 gigs of memory or even 2 gigs of memory, um, for one, you might end up with slow performance because not enough stuff can get in and out or crashes and stuff like that. But where was I going with this? That's why okay, I just lost my train of thought on that. Completely lost it. That's funny. All right. Anyways, let's move on. We're getting stuck on this for too long. What's next? In C++, you can use pointers to access and change. Oh, that's what it was. You can access every memory location in your computer if you want to and see what is in there. Um, I know that Cherno does a really good job of showing this. That's because the program he uses for text editing is more built for seeing memory. VS Code does have it as well, but it's not as good in my opinion. But if I knew how to access memory and look at it, it'd be a different story. I'm still working on learning that sort of thing, especially when it comes to programming C++. Now, for HTML and CSS, a lot of these other languages and stuff, they may not use that so much, but I don't know. Anyways, this is a powerful but risky. Let's see. So let me reread this again. In C++, you can use pointers to access and change memory directly. This is powerful, but also risky. If you use a pointer the wrong way, you could accidentally change or damage other parts of your program's memory. Program's memory, not your PC itself. So if you access a location and put something in there. I don't know exactly what that means by that. Um, Hopefully we'll get into that later. It's going to talk about it right here, I get actually. In the next chapter, you will learn how to create memory manually using pointers with the new keyword and how to use it and how to free it using delete. So we can create in the next chapter, you will learn how to create memory. I'm going to type this down here. That way you can read it too and stuff because I may be saying this wrong. I really hate to tell people wrong things, but it happens. So maybe I'll have it better in memory if I type it in the next chapter. You'll learn how to create memory manually using pointers with the, and I'm going to put this in parentheses because I can't label it red like they have it, new keyword and how to free it using, see, when I slow down reading it, it makes a lot more sense. How to use the delete keyword. I'm going to put that in there too. They have it at the end of the new. Okay, so there is a way to do all this. Like they're saying, using the new keyword to manually create memory, using the delete to delete that memory. I'm going to tell you right now, if you're new to C++, I would definitely do a thorough learning on new and delete. Um, if you use this in a large program, you can typically maybe crash your program or cause a memory leak on your PC, or maybe even in your program. I'm not sure exactly how that works, and that's why I'm saying thoroughly research this. Understand the new keyword and the delete keyword. Cherno goes through that really well in his YouTube videos. I've watched several of them. I still got quite a few more to watch to keep learning this stuff, but I can tell you right now, um, when you run a program, if it runs consistently and stuff like one of my videos and stuff, I had it printing up 0 consistently over and over in a loop, and that was taxing and maxing out my CPU, even with the computer that I have. It would do it to any computer. That is kind of like a memory issue because it is constantly filling up the memory as fast as it possibly can and pulling it out as fast as it possibly can. If the system is set up properly and stuff, it should be like a conveyor. It's throwing something in and pulling something out at the same time, basically using two hands at the same time. Um, that's about the best I can go with that. Let's get into the next part of this right here. The last part for the tutorial right here. We're already at 43 minutes because I'm talking too much, I think, but in C++, new and delete. Now, I'm not going to do any of these examples because I know how troublesome this can end up being and stuff if you're not really familiar with it. The new keyword lets you manage memory yourself. In the example below, we create memory space for an integer using new, storing the value of 35 in it. Actually, I can go ahead and type it out, the example and stuff, but I'm not going to run it. I know typing it out's one thing, running it's a different thing. Store the value 35 in it and print it using the pointer. Okay, so I'm going to leave this down here. I'm going to go ahead and clear all this code out right here. I'll go ahead and type this example in. So we got int uh, pointer uh, new int. Okay, so we're creating a memory location if I'm not mistaken. In the example below, we create memory space for an integer using new. So this is the new keyword right here that we're using. And we're creating a memory location for an integer. We don't have it declared, we're just creating it. basically what we're saying was we're creating a pointer, an integer pointer. We are calling it, we are giving it that variable name, and it's going to have the value of whatever value this integer has right here. This is the new location for it. In fact, this may right here kind of explain it when I mouse over this right here. Void pointer dereference operation new standard size. So it's going through right here and saying a bunch of stuff. I don't fully understand all this. These are replaceable signatures. Okay, so I don't think this really has anything to do with what we're, yeah, that's more confusing than what I was just looking at. So the next part right here, after that, we are going to dereference pointer and give the variable a value, 35. And then after that, we are going to output PTR. And this may not be as scary as what I'm making it sound to be and stuff. I mean, like I said, I've got this right here. I know it's fine. There's nothing dangerous about this. The system's not going to crash. It's not going to slow anything at all down. But what this keyword right here is doing is creating a location for this right here. I do know from watching Cherno's videos, when you create something new like this, when the program ends, you also need to delete it before the program ends, or else you end up with a memory leak. And that's why I'm not going to run this. Like I said, I would thoroughly research new and delete before using it, because in this case, they're not deleting new. So you're getting left with this right here being saved to that location, which means that in my computer, if I was to run this program, that location would be stuck right there until I deleted it. I don't even know if it would leave out of the system and stuff once I closed down once the program ended. I really don't. And that's why I'm not going to run it. It's just kind of an example. And until I actually run it to where the compiler sees it and makes it, nothing's being affected. It doesn't do anything until the compiler sees it and does something with it. And in this case, since I'm not running it, the compiler's not seeing it. I'm only seeing it right here, and that's as far as it's going. It's just basically on the screen. So here's an explanation of it. So the int new right here part creates memory space for one integer. So it's 8 bytes being created. 8 bytes of storage being created and stuff for this program. PTR stores so this right here is going to store the address of that space. Stores the address of the space, yeah. And then this right here part stores the number 35. And then this right here part prints the value. So we use new to create memory and PTR to access it. Like I said, there's just not enough information there for me to trust to run something like this. In fact, for doing this, I think I will go ahead and look up Cherno's video on new and delete for pointers, and go ahead and post that into the link. That way, if you do read this and stuff, you should probably check out his video before even attempting to run something like this. Because next we're going to get into the delete keyword. When you create something new, it's your job to remove it when you're done. So if we were to run this, we don't have the delete in there, so it's obviously being saved in there. To do this, use the delete, and at the end of this, I guess the way this should write is once that's printed out, you should have delete PTR stated, and that should delete the new integer that you created in your memory. This tells C++, I'm done with the memory, you can clean it up now. But since I haven't run this, it didn't even create the memory. There's a little comment section here. What happens if you forget to delete? If you forget to delete your memory, your program will still run, but it may use more and more memory over time. So this is more like a warning right here. If you forget to delete memory, your program will still run, but it may use more and more memory over time. Basically saying that if I was to run this without the delete in there, I think, it would continuously create more and more spots for this right here to be stored in, and it wouldn't remove it. So I'd end up having a slot for integer. If I ran it again, I'd have another slot for integer, and it wouldn't leave. It'd stay in there. Um, if I'm not mistaken, when you shut down a PC and stuff, it's supposed to clean out the memory, but again, I don't know. This is called memory leak. When you leave it in there, leave one in there, leave another one in there, leave another one in there, even after the program runs. Over time, it'll fill up. So, like I said, a lot of caution on that. That's why I didn't run it when I first put it on there. That's why I'm still not running it yet, because I still want more clarification on it before I do it. I'd like to know exactly what I'm doing before I do it. So this is called memory leak, and it can slow down or crash your program over time. So if you run this enough times and stuff, you can keep creating slots. Yes, you can eventually fill it up, and it's where nothing is going to work until you shut down your PC to wipe the memory. And I believe when you shut down your PC, it should empty out the memory by shutting everything off and removing all the power from it. But I can't say for certain. I can say though that if you really want to clear out your RAM, in a sense, most of the time you shouldn't have to do this because it should do it on its own. When you turn it off is one thing. There's still electrical current in a computer even after you turn it off. Even when you unplug it, there's still electrical current. You want to wipe it completely and make sure that the memory is completely emptied out. Shut down the PC, unplug the power from it, open the PC up, and actually pull the RAM chips out of your PC. That is the only way to do it because there is a battery on the motherboard most of the time that will hold for power outages. Eventually, the battery will stay charged up, but eventually the power will end up leaving, as far as I know. It's kind of like the old two TVs. This was something that they tested many times, and it was actually true. So an old tube TV made back before flat screens were even out. Um, if you had an old tube TV, you powered it on, you turned it off. If you turned it off and you actually took a bat or something and smashed the glass in front of it, you'd see sparks coming out of it. If you turned it off and unplugged it and still did the same thing, it's possible you could still see sparks coming out of it. Now, it's not a huge electrical current, but there's still a little bit of electrical current stored in there even when it's unplugged. Eventually, it will go away, it will fade off. It's no different than a battery. A battery holds so much power in it, but over time, that power fades. So, like I said, when I'm done with this video and stuff, I'll be sure to put Cherno's video of memory or for the keyword new and delete in the descriptions right there. That way, if you want to go there, you can find it. Also, I'll put in the link to the other source that I have. That way, if you really want to get into creating memory locations, you can. Right now, this is not really important. We're not creating any program big enough to need to do this right here. Most of our programs that we were running and stuff is maybe using up a grand total of 4 to 16 bytes, maybe 24 bytes at max when we run a program. Even I think that Battleship program that we ran a few videos back, that may have used 16 bytes total. 16 bytes compared to, I think mine runs 32 plus gig. So um, it's very little. And yeah, I would probably have to run this a few hundred, maybe even a few thousand times and stuff in order to do something like that. But anyways. So we're just kind of discussing this stuff again. I'm not going to run a program like this. So they got another one right here using new and delete with arrays. You can also use new keyword to create dynamic arrays. Note for arrays, use new and then square blocks, delete and square blocks for single variables. At this point in time, when it comes to this new stuff right here, the new and delete, it's not new information, but the new and delete keywords. If you really want to learn about this, I'm not even going to go through any more of this. For myself, I will, but I got other sources I'm going to use, and I'm going to get word for word these sources down before I start playing with it, especially since I know I don't need it. I imagine a game like World of Warcraft, you've probably played that, or Hearthstone, or uh, any other game, Rise of Kingdoms and stuff. I imagine they probably use these a little bit in their code, but I don't know. So, um, I'm gonna go ahead and move on. Functions are something we can deal with. In fact, I think that's going to be it for this video. Like I said, I'll leave a few links if you really want to study new and delete and understand them better. I'm working on understanding them better myself, but I know I don't need them right now. I would like to know about them, but I don't need them right now. So I'll keep studying up on them to learn about them. So yeah. But yeah, in our next video, we'll get started on functions. Functions are a little bit funner and easier. There's nothing to worry about with those. That's probably why they left memory management down there at the bottom of the tutorial. But I would definitely get used to understanding the new and delete features before you actually use them. In fact, you can probably even find somebody else can ask about it. I would suggest even like a doctor and stuff. When you go to a doctor and you get a diagnosis for a problem and stuff, you may go see another doctor and ask about that. Well, this is the same thing. You go ask somebody about it, go ask another person about it, go ask another person about it, check multiple sources, find out what you can about it before you actually start using it. So, anyways, I think that'll be it for this video. Like I said, next video we'll get into functions. That's a little bit better, easier, funner. Yep, funner. So, until next time, thank you.